Hello Year 8s, this is lesson 9 in the forces, waves and generating electricity. Now, reflection. When waves such as light or water waves hit a flat surface, the waves bounce off and are called a reflection. Exactly the same thing happens with sound waves as well. That reflection, when the sound waves bounce off a flat surface, we call an echo. Echo, echo. Now, unfortunately, you do not have this handout, but we can still go through the experiment. And even though it says in your book, stick in the Year 8 law of reflection handout here, you can still write a little bit of this down, okay? So I'd like you to start off with your prediction, which is when an incident light ray strikes a plane or flat surface like a mirror, I think. Now, once you've written that, we're going to be looking at the angle of incidence and the angle of reflection. You've got one of three options. You think, so you're going to write in here, I think that the angle of incidence is going to be greater, equal to, or less than the angle of reflection. I'm going to say it again. The angle of incidence is going to be either greater, equal to, or less than the angle of reflection. Now, before you write in your prediction, let me try and explain what these mean. We have a light ray coming from a bulb, right? There it is. It's coming from a bulb and it's going in this direction. In actual fact, the light ray is a very thin strip. So just imagine you got a bulb and then you got a piece of card with a small hole cut in it. That means that the ray of light is very thin, like this pink line here. Now, the angle of the incident ray, that's the ray that's coming from the bulb, is from this normal line here, this imaginary line, that gives us a reading of 20 degrees. Okay? Do you think the reflected ray, remember it's going to reflect off this mirror here, do you think the reflected ray will be A greater? Do you think it's going to look like this? I'll try that again. Oh dear, this isn't working very well. Hang on. Got it. Do you think that the angle of reflection is going to be A greater? Or do you think the angle of reflection is going to be about the same, equal to, as the angle of incidence? Or do you think the reflected ray is going to have less of an angle? It's over to you now to write up your prediction on that sheet where it says stick in your Year 8 law of reflection handout here. Okay, so that's greater, that's about equal to the angle of incidence, and this angle is much, much less, isn't it? Look at that. So which one do you think? Anyway, over to you. Now, these are the results that we actually got. This is ray number 1. And its angle of incidence, this angle here, is about 20 degrees. And the angle of reflection is also about 20 degrees. If we then have a look at the pinkish line, this is incident ray number 2. Its angle of incidence is about 40 degrees, and its angle of reflection is also 40 degrees. If we then finally have a look at the final light ray coming in, it has an angle of incidence of approximately 60 degrees, and its angle of reflection as that light ray comes outwards, having hit the mirror here, is also 60 degrees. On this page, we can therefore construct a results table using a ruler, and we've got the angle of incidence in degrees and the angle of reflection in degrees. Angle of incidence 20, angle of reflection 20. Angle of incidence 40, angle of reflection 40. Angle of incidence 60 degrees, the reflected ray is 60 degrees. What is our conclusion? The angle of incidence equals the angle of reflection. That is the law of reflection, and we can use that knowledge to construct a ray diagram for a periscope, and you can see that right here. So a little boy with a periscope that is going to have 2 mirrors within it, one here and one here. And what is going to happen is the rays of light are going to come in like so, reflect off the first mirror like so, and then enter his eyes, boom, like so. The arrows show the direction that the light ray is travelling, and it's exactly the same with this picture. This person has got a camera mounted on a periscope. The reason that he's got that is because there's probably bullets and shrapnel flying overhead. That looks like a trench from the First World War or Second World War. So let's have a look at this periscope here. Now this eye is unable to see this soldier because there is a wall in the way, but he's going to use this periscope here to view this soldier. Let me explain. Once again, I'm going to attempt to draw in some lines now. It's going to hit the first mirror. It's going to reflect downwards. It's tricky. It's tricky using this machine, but you've got to give it a go. It's going to reflect downwards, bang, like so. Fill in the gap there. And then it's going to reflect off mirror 2. No, that's no good. It's got to be right on the mark, this has. Well, I tell you what, I might be able to do it the other way. Boom, like so. Okay? It's not perfect, but it gives you an idea of what is going on. So, how does the eye see the soldier? Light rays are reflected off the soldier. They move in this direction towards mirror 1. They strike mirror 1. Actually, and they reflect off at 90 degrees. Then the light ray travels on downwards and reflects off mirror 2 also at 90 degrees. And then the light ray enters the eyeball. Remember, your eyes receive light. You don't look at someone's eyes and it looks like 2 torches or 2 bulbs, yeah, blaring out at you. That would be right spooky. It's not the case. Eyes take in light. So, let's move on. Ooh. Homework 3. Use the wave trace to answer questions 1 to 4 below. You have a go at that, and then we'll go through this in the next lesson. Well done.